So we have the PacBio. Um, First we have Ray Clean here, and the second we have Ting Ting Zhu. She is field application bioinformatics support from PacBio. Yeah. So now take it Ting Ting. I give everything to you now. Thank you again. Yeah.
Thank you, Dr. Loy. But you have to wait first. I will go first and then Ting Ting will come next.
Okay,
Yeah,
perfect. Yeah.
so okay. All right, let me share my screen.
Can
Okay,
you please
one.
swap your display? Swap your display.
Yep. 1 second. Let me do it again.
Mhm. Okay, perfect. We see the full screen now.
Okay. All right. Okay. All right. Thank you so much, everyone, for spending your Sunday night with us, and thank you so much, Dr. Loy, for inviting us to come to this platform to introduce about our long read platform, as well as how we can actually contribute to the microbiome research, as well as like microbial whole genome sequencing. Okay, so just to introduce myself, my name is Ray. So I'm the territory account manager for Southeast Asia, uh, yeah, for PacBio. So for my presentation, I will start by introducing about PacBio first, and then after that, I will go into the different applications that is being run on our PacBio platform for microbial research. And then after that, I will pass on to Ting Ting to actually go through some of the tools to actually, do whole genome sequencing, shotgun metagenomes, as well as 16S sequencing. Okay, so I will start my presentation. Okay, so yeah, so just to introduce about PacBios first. So for PacBio, our mission is to actually enable the promise of using genomics data to actually better human health. And in PacBio itself, we are a company that actually have both the short and long read sequencing so that we can actually offer the best technology for different types of applications. So for the long read sequencing side, we actually have two different sequencers right now, which is one is the Sequel 2E and the Revio, whereas for the short read sequencer, we have the own source system. So for the Revio is our newest instrument that is just launched, I think 1.5 year ago, where you can actually sequence up to 1,300 long read human genome in a year. Whereas for Onso, it's our state-of-the-art short read sequencer, which can actually, generate more than 90% of the reads that are above Q40. And then in our R&D pipelines, we are also coming out with a benchtop long read, as well as a high throughput long read, as well as short read. So with this multiple, portfolios that we have for our platform, we are able to address different applications. For example, rare disease, cancer genomics, and as well as the focus of today's topic, which is microbial and metagenomics. And we don't only, is able to offer results just on the DNA level. So we can also, do on the RNA level as well as the epigenetics side as well. And we partner with different partners to actually offer end-to-end solution to our customers. So for example, we partner with Twist, 10x Genomics, Agilent, or even like Zymo for some of the microbial applications on the upstream workflow. And then we partner with people like Hamilton, Ticken for the automation part to scale the workflow. And as well as the bioinformatics side for like Google Health, QIAGEN, and NVIDIA on the downstream bioinformatics part. Yep. So just to go into some of the basic of our long read sequencing. So today our topic will be mainly focused on long read, right? So our basis of our long read sequencing is called hi-fi sequencing. So what can hi-fi sequencing generate is reads that are both long, up to 25 kilobase pairs, and highly accurate, up to 99.9% accuracy. So what how do we generate hi-fi reads is we will usually start from a high quality double-stranded DNA. And then what we will do is we will actually ligate the smart bell adapters on the both side of the double-stranded DNA. And then we will anneal the primers with the DNA polymerase. And then after that, we will actually sequence this circularized DNA in repeated times. So we will sequence it multiple times to actually generate a lot of these different sub-reads. And then we will collapse all these sub-reads together to form a consensus sequence called a hi-fi reads. And with this hi-fi reads, it's like what I mentioned, it's 99.9% accuracy, which is the most accurate long read you have right now in the market. And it can actually generate reads that are up to 25 kilo base pairs. And yeah, just to reiterate my point again, so our long reads, we can generate reads that are 10 of kilobases in length. It's 99.9% accuracy. And then because we are actually sequencing the individual DNA molecules itself, right? So there's actually no bias in terms of GC content from all the PCR processes. And because of this, we are also able to get the DNA methylation information without any special library prep. So you don't need to do any bisulfite sequencing to actually get the 5MC data. So, because we are actually directly sequencing on the DNA molecules itself. Yeah, and just to reverse back to this platform itself again, just to show you, this is our latest sequencer, which is called the Revio. So for the Revio, we can actually generate up to 360 gig of hi-fi yield per run, which is 4 human genome. So we have 4 different stages, which each stage can actually generate up to 90 gigs of data, which is a 30x human whole genome. And each of the sequencing run take up to 24 hours. And like I mentioned, the read length that you generate will be around 15 to 20 kilobase pairs, and it will be 99.9% accuracy, which is Q30. And you will get the 5MC data together from the sequencing run itself. Yeah. So, just to, before I go into the microbial genomic side, just to, reiterate some of the trends, not only on microbiome, uh, for with our current hi-fi sequencing, we can actually, generate whole genome sequencing data that is without any gaps from all the, a lot of the structural variations, repeat expansions that were not able to sequence properly on the short read sequencing. But now on hi-fi sequencing, we can actually, sequence through those dark areas. And the data that we generate are also in collapsed haplotypes where you can actually, separate the paternal and also maternal allele. And like I mentioned, you will get your methylation information directly from the sequencing data. So you don't need to actually do bisulfite sequencing to get those epigenetics information. And on the RNA side as well, we do have our Kinetics workflow, which can actually offer you isoform level information, both on bulk RNA as well as single cell RNA. And of course, lastly, on the microbiome side, for our 16S sequencing, because we are doing full-length 16S sequencing, we are able to go down to species and strain levels compared to V3, V4 sequencing on the short read sequencer. And on the shotgun metagenomic side as well, if you are doing shotgun metagenome assembly, we are able to generate more max or metagenome assembled genomes compared to short read sequencing.
Hi, hi, Ray. Hi, Ray. Can I ask a question uh,
Yes.
as previous slide?
Sure.
I have question about can I sequence the native on a full length on a from your kit?
Not yet. No. So for our RNA workflow is still based on cDNA. So we cannot sequence the direct RNA directly yet. But if let's say you do want to look at some of the RNA modification, right? We do have some papers that some researchers did do some pre-treatment during the library on the cDNA side to enable them to actually, identify those RNA modifications. I can actually share some of the papers to you if you are interested.
Yeah, thank you.
Mm.